Hello, and welcome to Backer Breaks It Down. In this episode, we're going to discuss angles and their measures. We'll classify angles by their measures, and we'll also apply the angle addition postulate. So, recall that an angle consists of two rays with a common endpoint. The rays are the sides of the angle, and that common endpoint is the vertex of the angle. We can show measurements of angles. If they're ever given to you in the diagram, they'll usually be on the interior of the angle. So they'll be in between the two rays. And a point on the exterior, well, that's the point that's not on the interior. As you know, you can classify angles by their measures: acute, right, obtuse, and straight. You probably know this from grade school. So how do we step it up a little bit? Now that we're in high school, we talk restrictions. So for example, an acute angle has a restriction of 0 degrees, which is less than the measure of the angle, which is less than 90. So namely, an acute angle has a measure between 0 and 90 degrees. So anytime you encounter a restrictions problem, you'll want to look at this page in your notes to get those inequalities or equations, but namely the restrictions problems use the inequalities. Okay, two angles are adjacent angles if they share a common vertex inside but have no common interior points. So in the diagram to the right, angle RSP and angle PST are adjacent angles. Their common side is the ray SP. Now, the angle addition postulate basically says if I add two smaller angles together, I get a new big angle. So I can say that the measure of angle RSP plus the measure of angle PST equals the measure of that big angle RST. As you know, two angles are congruent angles if they have the same measure. Look for identical markings. I call them arc marks. So use the diagram to answer the questions below. Explain your reasoning. Is angle DEF congruent to angle FEG? Why, yes, they are. They're both 45 degrees. Sorry, let me get my pen. Yes. What about angle DEG? Look at it. 45 plus 45 is 90. And angle HEG, what does that little box mean? That it's a right angle. And what do we know about right angles? That they're 90 degrees. So yes, these two angles are indeed congruent. Are DEF and FEH adjacent? Yes, they're angles that are side by side. They share side EF. They have no common interior points. But what about angle GED? See it? And angle DEF. These are not adjacent because one is inside of the other, and they have to be side by side angles and share a side, not be inside. Use the angle addition postulate to find the angle measures represented by each letter. So we want to find x in number 5. Now they say that this is 1/4 of a rotation, so that's 90 degrees. So if I subtract 15 and 21, I'll get the measure of my missing angle. So this angle is 54 degrees. In number 6, we want to find y, and we're working with a half rotation. A half rotation would be 180 degrees. So if I subtract 41 and 37 from 180, I'll get the measure of angle y, which is 102. And in number 7, we're going all the way around. That's 360 degrees. So I need to subtract the given angles from 360 degrees. And when I do that, I get 64. So this angle right here is 64 degrees. Notice that I don't want that whole big angle. I actually want half of that angle because it's made up of two congruent angles. So that means angle Z is 32 degrees. Restrictions. So angle J is an acute angle. What are the restrictions on the measure of angle J? Well, I have them right here. The restrictions are 0 to 90 degrees. So the measure of angle J is in between 0 and 90 degrees. So what I'm going to do is I'm going to create a compound inequality, which 0 is in between. So like 3x minus 21 is in between 0 and 90 degrees. And now I'm solving this. So you may recall solving something like this when you were in Algebra 1. The first thing we have to do is we have to add 21 to both sides. So if I add 21 here, I'm getting rid of it. Gotta be fair. Do that on the left, do that on the right. So that's going to give us the following. 21 is less than 3x is less than 111. So then the next thing that I have to do is I have to divide everything by 3 to get x all by itself. And then I'll get the restrictions on x, which is what the problem asked for. So we're looking at 7 is less than x is less than 37. And those are the restrictions on x. Use the angle addition postulate to find the value of x. Then find the measure of angle ABC. Remember, we can assume straight angles. So I can assume that the angle ABD is a straight angle. And as you know, straight angles have a measure of 180 degrees. So if I add these two angles together, I get 4x plus 12. And then this is equal to 180. And then I just solve this equation. So we are looking at 4x is equal to 168. Divide that by 4, we're going to get 42. And then remember to find the measure of angle ABC. ABC is given by 3x plus 8. So that's 3 times 42 plus 8. So ABC is 134 degrees. One more problem. Angle ABC is a right angle. So that means that angle ABC is 90 degrees. The ratio of the measure of angle ABD to the measure of angle DBC is 3 to 2. So that means ABD goes with the 3, DBC goes with the 2. Now, anytime you're working with ratios, put an x after it. So this is really 3x and this is really 2x. And then remember, they said that angle ABC was a right angle. So I can say that 5x is equal to 90. And then I can solve for x. So I get that x is 18. Now this problem says, what is the measure of angle ABD? ABD is 3x. So if I multiply that by 3, I get 54, and that's the measure of angle BD. So there you have it, angles and their measures. We went a little bit beyond acute, obtuse, and straight. We talked about restrictions and the angle addition postulate. And that's how Backer breaks it down.